Students, in this lecture, we will discuss about irrigation scheduling based on soil moisture depletion approach. As we know that irrigation scheduling is very important because through this approach, through this scheduling, we apply right amount of water by right method and at right time to the plant. The soil moisture is very important. If soil moisture is more than plant requirement, definitely it cause harm to the plant through various means. And if irrigation is applied in low amount, then soil our plant requirement is not fulfilled. So, adequate amount is very important. That is why we approach through a correct method or through a good system. That is why there are different type of irrigation scheduling. And we have discussed about the irrigation scheduling based on climatological approach in which we use IW irrigation water and cumulative pan evaporation, and this lecture is already uploaded on YouTube and you can watch this lecture. And today we will discuss another approach of irrigation scheduling, that is soil moisture depletion approach. Actually, this approach is more scientific, and this approach is used to know what is the exact amount of water required by the plant, or what is the drought resistance, or what is the moisture sensitivity of the plant. So, this method is generally adopted by scientists. And in this approach, first we have to know what is available moisture. This is very important. The all moisture or all water present in soil is not available to plant. Only a small part or proportion is available to plant, and that amount is known as available moisture. And this available moisture or available water is between filled capacity to permanent wilting point. Actually, these are some soil moisture constant characteristics, and in brief we can understand in such a way that suppose this is the soil particle and a water film is attached to this particle. Soil particles are attached with the water molecule, or we can say that soil moisture or water molecules are attract or adsorbed to this soil particle or collide. So, this immediate layer is tightly held, then this is the second layer of water, this is third layer of water, similarly it is the fourth layer of water. As this distance increases, the moisture which is held by a soil particle, the pressure or the force become less. So, this is tightly held, this is less held, this is very less held. So, as the distance increases, the pressure or the force by which moisture is held become low, and that is why this water which is away from soil particles is available to plant. So, that is why suppose this is the particle and the first layer, second layer, third layer, then this water is available to plant. This is available with the least force, and this availability requires some force, and the water which is immediate vicinity with the soil particle is tightly held and not available to plant. So, that is why the total moisture in soil is not available to plant, and the moisture which is not available to plant with the same ease. The highest ease of availability is at filled capacity. Suppose this is a soil column, and it is filled with the water. Suppose this is filled with the water, soil column, total saturated, then the water in excess drained, that is known as gravitational water. This is drained easily. Then water remained in soil is held by some force, and that force is minus 1/3 bar, and that is known as filled capacity. Then moisture reduces through transpiration or evaporation, then this pressure increases 1 bar, 2 bar, 3 bar, and as the moisture is decreasing, this pressure is increasing, means moisture is tightly held by soil particles. If it is 3 bar, means 3 bar pressure is required to detach the water molecule from soil particles. More pressure is required. Similarly, at 15 bar, now at this point moisture is not available to plant. So this is the upper limit. If moisture is beyond this, then not available plant because it is gravitational water. So this is the first limit of availability, and this is the last limit of availability. So water between filled capacity to permanent wilting point is available water. Is it clear? So it means, but this pressure is between 1/3 to 15 bar. So if water is available at 2 bar and another water is available at suppose 8 bar, both are available, but here ease is more here. Only 2 bar pressure is required for extraction. Here more pressure is required. It means as the moisture decreases, suppose this is the limit of filled capacity and this is the limit of permanent wilting point, then moisture is decreases. So more and more pressure is required, more force is required for extraction. No doubt the available water is between filled capacity to permanent wilting point, but the water which is available between filled capacity and permanent wilting point is not available with the same ease. जैसे जैसे मॉइस्चर कम होता जाएगा फील्ड कैपेसिटी से परमानेंट बिल्टिंग पॉइंट की तरफ, प्लांट्स को ज्यादा फोर्स लगाना पड़ेगा वाटर को एक्सट्रैक्ट करने के लिए. ये अवेलेबल वाटर तो है, लेकिन अवेलेबिलिटी का जो फोर्स है वो बढ़ता जाएगा. इसका मतलब जो मैक्सिमम अवेलेबिलिटी हो रही है, जो मैक्सिमम ईज है, वो यहाँ पे है फील्ड कैपेसिटी, नियर फील्ड कैपेसिटी, एंड हाईएस्ट फोर्स इज रिक्वायर्ड एट परमानेंट बिल्टिंग पॉइंट. इफ मॉइस्चर डिक्रीजेस lower than permanent wilting point, then plant have not so pressure to extract the moisture. That's why here wilting is start, permanent wilting point. So these points are very important to know what is filled capacity and permanent wilting point. And this approach is used for irrigation scheduling. So how this soil moisture depletion, suppose this is the soil column and it is irrigated, and after irrigation it reaches the moisture content at filled capacity and here permanent wilting point, and plant is growing here in this soil. Okay. So as the moisture content reaches filled capacity after irrigation, because some moisture is drained in response to gravity, that is gravitational water at the time of saturation, when water reaches at filled capacity, then this moisture is available to plant. Now moisture comes here, suppose this is minus 1/3 bar, suppose it is 2 bar, suppose it is at 8 bar, and permanent wilting point is at 15 bar. As the moisture is decreasing, plants have to expend more energy, require more pressure for extraction of moisture. So some plant can extract energy up to 8 bar, some plants can extract the water up to 10 bar, some can expend the energy up to 5 bar. It depends upon the root characteristics and moisture sensitivity. If plant can tolerate drought, means have more capacity to extract the moisture, then they can extract water up to 10 bar, 11 bar. And some are moisture sensitive. As the moisture reaches at about 15 bar, then their growth is adversely affected, and adverse effects are shown on plant. It means at 5 bar their growth and productivity is reduced, so we have to give irrigation at 5 bar. Similarly, if another plant like sorghum, it can tolerate drought effectively, so we can wait till the 10 bar or 12 bar. So it means the irrigation is given according to moisture sensitivity or drought tolerance capacity of plant. If plant can tolerate drought, it means they have capacity to extract the moisture even at high pressure, then irrigation can be given at this point. If suppose plant is moisture sensitive, then irrigation is given at a low pressure, means if it reach about 3 bar or 4 bar, then we have to apply the irrigation. So if we look into the filled capacity to permanent wilting point, the total is available water, but according to plant nature and their capacity, sensitivity, drought tolerance capacity, they cannot extract the total available soil moisture. So this is soil moisture depletion approach. So how much moisture depletion is there? So it is in pressure based, 1 bar, 2 bar, or we can say suppose it is 100% moisture, available is 100% moisture, then depletion start, suppose it is 10% depletion, it is 20% depletion, this is 30%. Now at here it is 100% depletion of available soil moisture where soil reach as permanent wilting point. तो अवेलेबल मॉइस्चर को हम 100% मान लें तो फील्ड कैपेसिटी पे 0% डेप्लीशन है. फील्ड कैपेसिटी से जैसे ही मॉइस्चर कम होना शुरू होता है 10% डेप्लीशन हुआ, 20% हुआ, 30% हुआ, 40% हुआ, 50% डेप्लीशन हुआ. तो उसके अकॉर्डिंग देख सकते हैं कि कितने डेप्लीशन पे हमको इरिगेशन देना है. तो जो मॉइस्चर सेंसिटिव क्रॉप है इन जनरली इरिगेशन इज गिवन एट 25% डेप्लीशन एंड इन जनरल फॉर मोस्ट ऑफ द क्रॉप 50% डेप्लीशन. और ड्रॉट टॉलरेंट जो होती हैं जैसे सोरगम है उसमें 75% डेप्लीशन तक अलाउ कर सकते हैं बिकॉज सोरगम कैन टॉलरेट ड्रॉट इफेक्टिवली. सो दिस इज द सॉइल मॉइस्चर डेप्लीशन अप्रोच. सो दिस इज डेप्लीशन इज अवेलेबल मॉइस्चर. ये हमको ध्यान रखना है कि जो डेप्लीशन है टोटल सॉइल मॉइस्चर नहीं है, ये अवेलेबल सॉइल मॉइस्चर है. ये अवेलेबल सॉइल मॉइस्चर किसके बीच का है? बिटवीन फील्ड कैपेसिटी टू परमानेंट बिल्टिंग पॉइंट. सो इट मीन्स फॉर दिस अप्रोच फर्स्ट वी हैव टू डिटरमाइन what is the moisture content at field capacity, then what is the moisture content at permanent wilting point, then accordingly irrigation is given. For example, for in field capacity and permanent wilting point, suppose at field capacity volume basis, suppose ये 21% इन जनरल होता है, 21% इन जनरल है एंड परमानेंट बिल्टिंग पॉइंट इज 10%. एंड सपोज BD is bulk density is 1.5 ग्राम पर क्यूबिक सेंटीमीटर. हालांकि बहुत ज्यादा है बट फॉर कैलकुलेशन ओके. सो नाउ फील्ड कैपेसिटी ऑन वॉल्यूम बेसिस कितना हो जाएगा? वॉल्यूम कितना हो जाएगा इसका? 21 इंटू 1.5 because it is PW and PV volume basis weight basis multiplied by bulk density. तो ये हो गया, इसमें 10 जोड़ दें हम तो 22.5 अप्रोक्सीमेट ये इतना हो जाएगा. 21.5 ये करीब सॉरी 32 या हम इसको ऐसे देख लें 21 का आधा 22 मान लें इसको 11 जोड़ दें 32 तो 31.5. दिस इज द वॉल्यूम बेसिस ओके एंड दिस इज PV is equal to 10 into 1.5 that is 15. So ये जो वॉल्यूम दिस इज वॉल्यूम बेसिस इट मीन्स इट इज जो हम निकालते हैं सेंटीमीटर पर मीटर. हम रूट डेप्थ अगर हम 1 मीटर मान लें तो ये हमारा 31.5 सेंटीमीटर पर मीटर. दिस इज सेंटीमीटर पर मीटर. तो इट मीन्स ऑन वेट बेसिस इट इज 11%. So volume basis available moisture is 11 multiplied by 1.5 और इसमें ये अप्रोक्सीमेट हो गया इसका 16.5 अप्रोक्सीमेट 16.5 सेंटीमीटर पर मीटर. सो दिस इज द एक्चुअली कैलकुलेटिव वैल्यू. और अगर हम इसको ऐसे देखें ये सॉइल कॉलम है, यहाँ फील्ड कैपेसिटी है, सपोज इट इज फील्ड कैपेसिटी, दिस इज परमानेंट बिल्टिंग पॉइंट एंड इट इज 21% moisture, it is 10% moisture. So here at it is 31.5 centimeter per meter, it is 15 centimeter. So ये जो range है, this range, this 31 to 15, this is the available soil moisture. So ये आ जाएगा 31.5 minus 15, that is 16.5 सेंटीमीटर पर मीटर. तो हमने यहां से भी इसको कैलकुलेट कर लिया, ये कितना आएगा और यहां से डिफरेंस भी हमने निकाल लिया. इट मींस अवेलेबल मॉइस्चर इज 16.5 सेंटीमीटर पर मीटर. ये हमको पता चला कि अवेलेबल सॉइल मॉइस्चर सॉइल वाटर इज इक्वल टू 16.5 सेंटीमीटर पर मीटर डेप्थ. ओके, सो अब सपोज एनी क्रॉप कैन टॉलरेट 25%, तो इसको मैं अप्रोक्सीमेट कर लेता हूं 16 सेंटीमीटर पर मीटर फॉर द कैलकुलेशन. Suppose a crop can tolerate only 25% available soil moisture, then 25% of 16 centimeter per meter, that is 4 centimeter per meter. इसका मतलब ये हुआ कि when there is a deficiency of 4 centimeter water, then we have to apply irrigation. तो हमने irrigation दिया, and this is the up to the their total saturation, then it reaches to field capacity, and when it is a field capacity and when there is a loss of 4 centimeter water per meter depth, then we have to give irrigation. Similarly, suppose depletion is suppose 50%. So 50% of 16 centimeter per meter, that is 8 centimeter. So दूसरी crop suppose can tolerate 50% depletion, then there is a 8 centimeter loss of water, then we have to give irrigation. Similarly, if it is 75% depletion, crop can tolerate, it is 16 centimeter per meter, then it is 12 centimeter per meter. So when there is a loss of 12 centimeter water, then we have to give irrigation, and available is how much? 16 centimeter. So this is the moisture sensitive crop which require irrigation just after 4 centimeter loss of water. It is moderately sensitive, it can tolerate 8 centimeter loss of water, and it is drought tolerant. It can tolerate 12 centimeter per meter loss of moisture. So generally the crops are irrigated at 50% depletion of moisture. So this is the soil moisture depletion approach, but this is the scientific approach and generally used by scientists. And suppose a crop, we are growing a crop and it is at a seedling stage or early vegetative stage, suppose, and we are giving irrigation at 25% moisture or 30% available moisture, then there will be irrigation and root will get sufficient water, then there will be no further root development, because root development is due to moisture deficiency, because roots goes into deeper layer in search of water. So in early stage we should not provide a sufficient moisture, otherwise root will proliferate on upper surface because there is availability of moisture. Suppose there is a mild stress, then root will go into deeper layer in search of water. So in early stage we should give irrigation at more moisture depletion, at about 50% or 60% depletion. If we are giving the frequent irrigation, then root will moisture and will remain on upper surface and there will be no proper root development. But at maximum vegetative stage, there is high transpiration, more water requirement. So if at this time there is a moisture deficiency, definitely there is huge impact on yield. So at this time there will be no soil moisture, so irrigation given at low soil moisture depletion, maybe about 30% or 35% or 25% in general. Similarly, at reproductive stage, and this time there is a flowering, there is seed setting, and no vegetative growth, and transpiration ratio or rate is not as high as maximum vegetative stage. So at this time plant can tolerate some moisture stress. So irrigation may be given at high ratio about 70% or 75% depending upon the crop nature. But at early stage we should provide a mild moisture stress, not severe stress. Mild moisture stress is required for root development. अगर हम सीडलिंग स्टेज में जल्दी इरिगेशन करेंगे तो रूट्स को पानी मिल गया तो रूट्स नीचे नहीं जाएंगी क्योंकि उनको पानी लगातार मिल रहा है. तो ऐसी स्टेज में हमको इरिगेशन को थोड़ा सा लेट करना चाहिए और मॉइस्चर का डिप्लीशन होने देना चाहिए ताकि जैसे जैसे पानी कम होता है जाए रूट्स भी नीचे जाएं वाटर को एक्सट्रैक्ट करने के लिए, तभी रूट डेवलपमेंट होगा. तो यहाँ अर्ली वेजिटेटिव स्टेज पे सॉइल मॉइस्चर डिप्लीशन को अलाउ करना चाहिए. हम उसको 50-60% तक ले जा सकते हैं, यहाँ ज़्यादा डिप्लीशन देना चाहिए. वेजिटेटिव स्टेज में ट्रांसपिरेशन बहुत तेज हो रहा है, लीफ डेवलपमेंट बहुत है, ड्राई मैटर प्रोडक्शन बहुत हाई हो रहा है. अगर ऐसे टाइम पे मॉइस्चर स्ट्रेस आता है तो यील्ड पे बहुत इंपैक्ट होता है, बहुत क्रिटिकल स्टेज होती है. तो इस टाइम पे हमको सॉइल मॉइस्चर डिप्लीशन कम पे ही देना चाहिए. जैसे ही सॉइल मॉइस्चर कम हो तुरंत हमें इरिगेशन करना चाहिए. And at reproductive stage, no such huge amount of water is required. So we can allow a more water depletion, about 70%, 60%. But this 60, 70 depends upon the crop. For example, sorghum, we can allow a more moisture depletion, 75%, 80%, because sorghum can tolerate drought. But potato cannot. Potato के केस में हम ज़्यादा soil moisture depletion नहीं कर सकते, नहीं तो tuber formation नहीं होगा. मेज moderately sensitive, तो मेज में हम 50% से ज़्यादा अलाउ नहीं करते हैं, नहीं तो उसमें सीवियर इम्पैक्ट आएगा. सो दिस इज द सॉइल मॉइस्चर डेप्लीशन अप्रोच बेस्ड ऑन field capacity and permanent wilting point. First determine what is the soil moisture. Suppose field capacity to permanent wilting point, moisture is 16 centimeter. Okay, so in early vegetative stage, suppose we are along 50% depletion, so it means if it's a 8 centimeter depletion, then we should provide irrigation. And early maximum, during maximum vegetative stage, only 25% depletion, 25% of 16 4 centimeter. It means when there is a 4 centimeter depletion, जैसे ही 4 centimeter moisture कम हो खेत में, तुरंत irrigation कर देना चाहिए. At reproductive stage, we can give about 50% depletion, for example, on 8 centimeter. Irrigation देने के बाद जब उसमें soil moisture में 8 centimeter की कमी आ जाए, तब हमको irrigation देना चाहिए. So this is the soil moisture depletion approach based on the soil moisture constant, that is field capacity and permanent wilting point. So in this approach, we should know what is the field capacity, Y weight and Y volume, and volume by volume is calculated with the help of bulk density. Then determine how much moisture is available between field capacity to permanent wilting point. यहाँ फिर इस बात को ध्यान रखिए कि ये soil column है, मान लीजिए, और यहाँ field capacity पे moisture है, और यहाँ permanent wilting point पे है moisture, and this is the available moisture. No doubt, this is available moisture. तो जैसे जैसे ये water कम होता जाता है, तो उसके जो soil chloride के साथ वो pressure बढ़ता जाता है, क्योंकि यहाँ what is the pressure? Only -1/3 bar. What is the pressure? 15 bar. तो इसका मतलब कि जैसे जैसे हम नीचे को जाते जा रहे हैं, moisture कम होता जा रहा है, pressure बढ़ता जा रहा है, 2 bar, 4 bar, 10 bar, 12 bar, 15 bar. तो इसका मतलब जो जितना available moisture है, वो same ease के साथ available नहीं है. Easiness, moisture availability की धीरे धीरे कम होती जाती है. So this is the reason that we should not wait up to the permanent wilting point, because here more pressure, 15 bar pressure is required for the availability. So some plants require irrigation up to this point, some require up to this point, and that's why this is the depletion, percentage wise depletion. That's why we calculate the how much percent depletion we can allow. Allow means अगर उसके बाद depletion होगा तो severe impact आएगा growth और productivity पे. That's why this approach is scientific approach based on the impact of moisture on growth and productivity. So this was the irrigation scheduling based on soil moisture depletion approach. Thank you very much.